Today we will be estimating fractions. So let's take a look at how to estimate sums and differences. Sums is addition and differences is subtraction. Well, we are going to round to 0 if the numerator is much smaller than the denominator. So let me give you some examples. If we had maybe like 1/4. See, 1 is much smaller than 4, so that's when I would go ahead and round that off to 0. I just cross off that fraction. Or if I had something like 3 over maybe 12, that I would also reduce to 0 because 3 is much smaller than 12. One more example might be maybe like maybe 3 over 20. Again, 3 is much smaller than 20, so I go ahead and round that off to 0. I'm going to round to 1/2 if the numerator is about half the denominator. So for instance, if I had 1/3, see, 1's not much smaller than 3. If I looked at a 1-year-old and a 3-year-old, they're about the same. And notice how half of 3 is 1.5, so that's pretty close to 1/2. Another example might be maybe like 3 over 5. 3 over 5 is bigger than 1/2, yet 3 and 5 are pretty close to one another. 3 is about half of 5. And if I tried the next one, maybe like a 7 over 12. 7/12 is more than 1/2, but it's pretty close to 1/2, so I would call it about 1/2. Well, I'm going to round to 1 if the numerator is about equal to the denominator. So if it were something like 9/10, or maybe even a 10/12, even though those are 2 off, I'd still call this about 1. They're pretty close to one another. One more example would be like 4/5. 4 is pretty close to 5, so I'd call that about 1. So we're going to use that concept when we're estimating these sums and differences. So look at the 5 is about half of 11, so I would call this about 1/2. And 4 is about half of 9, so I would call that 1/2. And then I'd add those two fractions together, and I get 1 as the answer. Looking at our next one, here we have 6 over 13. Well, 6 is also about half of 13, so I would call that 1/2. 8 is almost 9, so I would call that 1. 1/2 plus 1, well, that would just be 1 and 1/2. Next one, we have 9/10. Well, again, that's pretty close to 1. This time we're subtracting, and 4 is about a half of 9, so I would have 1 minus 1/2, which would leave me with 1/2. Next one, now we have a mixed number, so we're going to have 1 and 1/2. 1 and 1/2 because 5 is about half of 8, so I called that 1/2, and I just brought down the whole number of 1. And then minus, and 4 again is about half of 7, so I call that 1/2. And then when I subtract, the 1/2s are going to cancel, so I'm just left with the number 1. Well, looking at our next one, we have another whole number, so we'll bring that down. And looking at 5 and 16, well, 5 is pretty close to half. 8 is 1/2, but 5 is still closer to 1/2 than it is to 0, so I'm going to go ahead and call that 4.5. And then I'll bring down the 2, and since this is almost 1, I'm going to end up adding an extra 1. So instead of calling this 2, we could have called it 3. So I just wrote the 1 now, since I already wrote the 2, and I'm just going to add up those whole numbers. We have 4 plus 2 plus 1. So that makes 7 and 1/2. And our last one of this type, we bring down the 11. Again, 3 is just about a half of 7, so I'll call that 11.5 minus, and this is 1. This is almost 1, so it's going to be minus 5 plus that 1. So this is going to make 6. So 5 and this 1 makes 6, and then I'm going to bring down that minus sign and take 6 away from the 11.5, which would make 5 and 1/2. So those are some examples of estimating sums and differences. The next type is going to ask us to estimate products and quotients. So here's the rule I use. When the fraction is less than 1/2, then I just drop it off. And so I round down, which is just dropping off the fraction. So for instance, if it was 11 and 3/7, 3 is less than half of 7, so I'm just going to cross that off and just go with 11. But if the fraction is more than 1/2, or 1/2 or more, I'm going to round up to the next integer. So again, if it was, let's go with 7 and 9/16. 9 is over half of 16. See, 8 is 1/2 of 16. So if it's 9/16, I'm going to just round this up. So I'll call it about 8. The squiggly equal signs just mean about. Well, that's the rule I'm going to use. So let's go ahead and estimate these products and quotients. So 2 is less than half of 5. So I'm going to just knock this off and just call it 12. And divided by, now 3 is over half of 4. So I'm going to round this up and call this 6. And so 12 divided by 6 makes 2. So over here, again, this is over 1/2. 11 is over half, so I'm going to cross that off, call that 18. And again, this is over 1/2. Half of 9 is 4.5, so I'm going to cross this off and call it 9. And do that division, I get 2 once more. 2 is over half of 3, so we'll call this 36. So notice I rounded up because over half of the 3. And we're dividing once more. 5 is over half of 7, so I'm going to call that 4. Do the division, and we get 9. And looking at our next one, we have a multiplication problem this time. Same sort of rule, though. 7 is over half of 8, so I'm going to change this to the next number higher. 3 is over half of 5, so I'm going to change this to the next number higher. And then multiply, and I end up with 40. Now that's a little bit higher than it typically would be. Sometimes with multiplication it's nice to round one up, round one down. You kind of get a little bit better representation, but that's pretty close to what we are. And remember, estimating should be easy to do and quick. It should not take a lot of time. If you take too much time estimating, you might as well just do the problem. So you've got to go quick, and it gets you just about to where we need to be. See, 1 is less than 6, so we're just going to knock this 1/6 off and just call this 5. 2 is less than half, so we'll just knock that off and call this 3. And multiply those two numbers, and we get about 15. Now, I know the number is going to be bigger than 15 because this 1/6 and 2/9 were bigger than the new two numbers I used, but it gives me a good approximation. So the 3/8 gets knocked off, I'm left with 12. Here the 1/6 gets knocked off, I'm left with 6. 72 is a good approximation of what that number is going to be. Well, a couple word problems here. It says a hallway has a length of 15 3/4 and the feet, and a length of 4 1/12 feet, and estimate the area of the hallway. Well, area is when we're going to multiply the length and the width. Now, kind of confused me because they said it has a length of this and another length of this, so I think they meant width here. And so I'll just add that in instead. And so a hallway has a length of 15 3/4 feet and a width of 4 1/2 or 4 1/12 feet. And they want to know the area. Well, area is just length times width. So we're going to multiply these two numbers. So we're going to go ahead and look at estimating here. Now this 3 is over half of 4, so I'm going to round that up to 16. 1 is less than half of 12, so I'm going to round this down, or just knock that 1/12 off and just call that 4. Multiply these numbers. 4 times 6 makes 24. Carry a 2. And 4 times 1 makes 4, plus 2 makes 6. So 64 square feet. So you can show it with the feet to the second power. Well, a 6-week-old puppy weighed 8 7/16 pounds. At 12 weeks of age, the same puppy weighed 17 3/8 pounds. Estimate how much weight the puppy gained between those two. So I'm going to subtract the smaller number from the bigger number. And so when I do that, I'm using the addition rule, which is the same as the difference rule, which says we're going to go by halves. And so 3 is about half of 8, so I'm going to call this about 17 1/2. And I'm going to take away, okay, that's a takeaway symbol, and then 7 is about half of 16, so I'm going to call this 8 1/2. So I subtract, the halves will cancel, so you're just subtracting 8 from 17, and that leaves you with 9 pounds. So the puppy gained 9 pounds in that time frame. Well, those are the types of problems you're going to see on tonight's homework. Good luck.